Okay, hi students. We have to, last time I showed you what were they, the similar figure and the congruent figure. Do you remember the previous video we have done it over the similar figure and the congruent figure. In that, what are the things with the same size and same shape in the congruent figure, and in the similar figure same shape but not, it may not be same size. Okay. Now here in this case, we are going to talk about in this chapter is not about the figures and all of that. We are going to talk about the similar triangle. We are going to talk a lot about the similar triangle. Now if you check this out, the similar triangle, lot about the similar triangle is what is nothing but in that similar triangle, a two triangle is similar. Then last time I showed you that if the two triangles are similar, then the ratio of their corresponding side, that means AB is correspond to PQ, BC corresponds to QR, and AC corresponds to PR. That is the ratio of the two corresponding sides. Ratio are equal. AB upon PQ is equal to BC upon QR is equal to AC upon PR. Can you see this? What are the conditions? If the two triangles are similar, then the ratio of the corresponding sides are equal and the corresponding angles are congruent. Can you see that? And the corresponding angles are congruent. If you check this out, okay, how these angles are congruent. Okay. For the thing, that means 1, 2, 3, 4, 5, 6. Okay, 6 part you will be getting over there. Now if I take it out, this part also is nothing but ulta. Ulta means what over there is for a triangle to be a similar, then you require a ratio of the corresponding side must be equal and the angles must be congruent. Then if this is congruent, then you will be getting what over there, the two triangles will be similar. Triangle ABC similar to triangle PQR. If you check this out carefully, that where there I told that if the triangles are similar, then the ratio of the corresponding sides are equal and the angles are congruent. Now I want what? I want the triangle to be similar. Now I'm taking up to be similar. You have to prove the triangle to be similar. So you require all this 6 part has to be proved over there, that the ratio of the corresponding sides are equal and the corresponding angles are congruent. If that are thing, then you can say the two triangles are similar. But what I'm saying over there, when the two triangles has to be proved similar, we don't need to go all the 6 part over that thing there. So we have to go only 3 parts of it over there. And what is that? I'll just be showing you that over here. In this over here, the test of similarity of a triangle. For a triangle to be a similar, we have to do some test. Okay, and then in that over there, no need of going for all the 6 part over there. You just need to go to 3 parts only. Now what is that over there? How many tests are there? There are 3 tests are there. That is, your first test is nothing but angle test for the similarity of a triangle. Then side test for the similarity of the triangle, and side angle test for the similarity of a triangle. That is your AAA test, SSS test and SS test. 3 tests are there. Now what are the 3 tests? It is like that what we have done in your 9th standard. Congruency of a triangle. Do you know that? We have done that. This is not new. Now there it is only the difference coming up there. In the congruency we have a congruent sides. The side has to be congruent. But here the side is not to be congruent, but it has to be, ratio has to be equal. Now let's go to the first part. I am explaining the first part. Angle test for the similarity of a triangle. Now for example, here they have given the triangle ABC. If you have over here, I'll be writing over here triangle ABC and triangle PQR. Now what are the things given over there? Can you see that angle A is congruent to angle P? Why? Because 40 degree, I have drawn a diagram and showed you, kept it over there. Then you will be having angle B congruent to angle Q because they are 60. And here if I write it over here, in this case is 80. Then angle C congruent to angle R. Okay. It is what? Each 80. Now therefore you can see that all the 3 angles of the triangle ABC are congruent to the corresponding angle of triangle PQR. Then I can say that triangle ABC is similar to triangle PQR by, you have over here AA test of similarity. By A test of similarity. Now A test of similarity. Now if you check this out carefully, here three angles are congruent. Now one more part I want to explain you that today. That for example, if I do one thing today, if I don't write all the three angles, I just wrote out two angles are congruent. Now for example, if you check this out today, if the two angles are congruent. Now if two angles are congruent, can you see that today? This is one angle is 40-40, the other is what 60-60. But what about the third angle? Third angle, you don't need to go. It is understood. You have done your 9th standard one property called as sum of the measure of all the angles of a triangle is equal to 180 degree. Do you remember that property? Yes or no? So all that property you have done that thing. The sum of the measure of all the angles of a triangle is equal to 180 degree. In this case, 40 plus 60 is 100. 100 you have to minus with 180. So 180 minus 100 you are getting what 80. So naturally the third angle has to be 80. Here also you can see 40 plus 60 is 100, 180 minus 100 is what 80, so you will be getting 80. So it is not necessary that you have to go for all the three angles. You can go for this test also. That is means what third wala no need to be if two angles are corresponding angles are congruent, there is no need to go for the third angle. Then you can say these two triangles are similar by a test of similarity. Instead of saying what a test, you can go for a test of similarity also. Next part. Okay. So this is what we finished with the a test or a test. 2 time A. 3 time A or 2 time A. That is what you can go through that way. Now we are going to go for the side test. In the side test, you can check it out over there that we have two triangles. Again, I will be going in the triangle ABC and triangle PQR. If I go to this triangle, then you have seen that they are not angles are being given, they are given the measures of the sides. Okay, and these measures are not congruent. Can you see that? Are they congruent? If you see AB and if you see PQ, they are the corresponding side, but their measures are not same. So what we have to do to here is nothing but we have to take the ratios of this side. That is what, can I take it up? AB upon PQ is equals to nothing but you have here 3 upon 6, and if you divide you will be getting the answer 1 by 2. That's my statement number 1. 3 1 the 3, 3 2 the 6. Same thing I can take it up BC upon QR. BC upon QR is equals to 4 upon 8. You will be getting 1 by 2. 4 1 the 4, 4 2 the 8. You will be this ratio is also you are getting but 1 by 2. And one more, the third ratio is what AC upon PR. AC upon PR is equals to what over here? 5 by 10 is equals to, again you will be getting 5 on the 5, 5 to the 10. That's also you can see this over there. So here you can see that over there that all the three ratios are equal. That is what you are getting 1 by 2, 1 by 2, 1 by 2. Can you see that over there? If all the ratios, three ratios of corresponding sides are equal, then can I say that triangle ABC is similar to triangle PQR. You have by SAS test for similarity. SAS test for similarity. Can you see that today? So this is how we finish the SSS test for similarity. Okay. So we can have side test for similarity, not SS. That is side. Sorry. SSS test for similarity. Now we are going to go for another topic, that is nothing but your side angle side test. Now side angle side test, in that if you check this out carefully, that you have two triangles. Again I will be having over here in triangle ABC and triangle PQR. We have what over here? In this case, the ratio of AB upon PQ. Can you see that AB upon PQ? Now AB upon PQ is 3 upon 6. That comes to 1 by 2. 3 1 the 3, 3 2 the 6. That's my statement number 1. And then you have here BC. You have here is BC upon QR. BC upon QR is also 4 by 8. Is equals to 1 by 2. 4 1 the 4, 4 2 the 8. You will be getting 1 by 2. And then this is your statement number 2. So from this I came to know that ratio of the two corresponding sides are equal. Now that is what here you can see that AB upon PQ will be equal to BC upon QR. You have from 1 and 2 we came to know about that. From 1 and 2 we came to know these two ratios are equal. And if these two ratios are equal, and can you see that the angle between these two corresponding sides must be congruent. And which is the angle over here? In this case is your angle B is congruent to angle C. You can see that the two corresponding sides are there and the angle between them must be congruent. So here you have your angle between them is congruent. So can I say triangle PQR and triangle ABC and PQR is similar to triangle PQR by, can I have here by SAS test for similarity? Yes or no? And this is how I finish the explaining all the three tests of the similarity, test of similarity of triangle, that is your AAA or AA, SSS test and side angle side test. And that is how on this basis we are going to do the next exercise, that is 1.3. Okay students, now we are going to start. Okay. Now students, we are going to go for the practice set 1.3, question number 1. That is all the whatever we have done that test of similarity of a triangle, we are going to do in this. So simple, it is very simple. Check this out. Let's read out the question first. Angle ABC is equal to 75. In this diagram, can you see that over there? Angle ABC 75 degree. Angle EDC is what? 75 degree. Can you see that both the angles are 75. State which two triangles are similar and by which test. Which two triangles are similar and by which test. And also write the similarity of these two triangles by a proper one-to-one correspondence. One-to-one correspondence. Now if you check this out carefully, that I will be first going in that two triangles. So which two triangle? Triangle ABC. You have a triangle ABC and triangle, you will be having over here DEC. You have a two triangle ABC and triangle DEC. Now in this triangle, if I can see this, that what are the things congruent? You have over here is angle, suppose I have over here is nothing but angle ABC. Here we have over here the angle ABC is congruent to angle EDC. Is congruent to angle EDC. And why? It is you can write it over here each 75 degree, or you can write given. You can also write given over there. This is the triangle ABC, angle ABC and triangle angle EDC are congruent because it is given in your question. Now you can see that in triangle ABC, C is there. In triangle DEC, C is there. So can you make it out over there that angle C is coming common for both the angle? So can I write it over here that angle ACB is congruent to angle DCE, and you have to write it over here is nothing but common angle. Can I write common angle? Can I write a common angle over there? So you can see this over there that in this two triangle I have proved the two angles congruent. If I prove this two angles congruent, that means no need of going for the third one. I have proved the two pair of corresponding angles are congruent. So can I say that the triangle ABC you have over here is nothing but which two triangle they are similar by A test. So how to write that over here? Suppose here in this case we have written over here that B is congruent to D. Can I have over here similar? And you will be writing B is congruent to D. And then you have a C and C is common angle. C and C is common angle because I am writing by a proper one-to-one correspondence. Angle B congruent to angle D. And C is congruent. So what will be that? A will be congruent to, can you see that over there? A will be congruent to E. A will be congruent to E. So here that is what the second part they told to write it by, write a triangle by a proper one-to-one correspondence. One-to-one means what? B congruent to D, angle C congruent to angle C, therefore A will be congruent to E. So triangle ABC is similar to triangle EDC. I wrote by one-to-one correspondence, and then you have to write it here by A test of similarity. A test of similarity, and that is what they asked over here. A test of similarity, and I finish with that. That is what state which two triangles are similar and by which test. So by which test it is similar? By A test of similar, and write the proper one-to-one correspondence. I wrote proper one-to-one correspondence. Okay. Okay students, now we will be going to the question number 2. In that you can see that are the triangles similar? If yes, By which step? Let's see the triangle first. Okay. Triangle PQR, you have given PQ ka value 6, QR ka 8, PR ka 10. In triangle LMN, you have LM is 3, MN is 4, and LN is 5. Now here, if you check this out carefully, that they have given mention about the sides of the triangle. They have not mentioned anything angles over there. So you can make it up. You remember we have a 3 tests coming up: angle, 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 and side, 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 and SAS test. Okay. So can you see that we will be going for the side, side, side? Let's see about that today. In triangle PQR, we have a triangle PQR and triangle LMN. So I have a triangle LMN. Now here in this case, can I take the ratio PQ upon LN, the ratio of the corresponding sides? That is 6 upon 3. 3 1 the 3, 2 2 the 6. So you'll be getting 2. So you got the statement number 1 as the ratio is what? 2. Okay, PQ upon LM is equal to 2. Now next is what we have is nothing but QR upon MN. QR upon MN. Now if I go for QR upon MN, that is 8 upon 4. QR ka value is 8, MN ka 4. Look at the diagram also. 4 1 the 4, 4 2s are, and you'll be getting here also 2. Can you see the ratio? You are getting 2. Okay. Then there is one more is a PR upon LN. PR upon LN. Now PR upon LN ka, if you check this out, here PR ka value is been given 10 and LN ka value is given 5. 5 1 the 5, 5 2 the 10. You got 2, and this is my statement number 3rd. So from this you can make it out that all the 3 ratios are equal. You can make it out that all the 3 ratios are equal. So if all the 3 ratios are equal, I'll be writing over here PQ upon LM is equals to QR upon MN is equals to PR upon LN. And from where I got it? I got it from 1st, 2nd, and 3rd. And 3rd. We got it from 1st, 2nd, and 3rd statement. Yes or no? So this is what I got it over there. Therefore, if the 3 ratios of the corresponding sides are equal, so can I say that triangle PQR is similar to triangle LMN? Can I have here triangle PQR is similar to triangle LMN? And you have to write it what? By SSS test of similarity. Now you can make it out over there that see this over there, all the 3 ratios are equal, so I kept it on all the 3s are equal, and from 1, 2 and 3 I got it over there. Therefore the triangle PQR is similar to triangle LMN by SSS test for similarity. Okay. Okay students, now let's go to the question number 8 of practice set 1.3. 8. In that here, if you check this out over there, in the figure seg AC and BD intersect each other in point P. Seg AC and BD intersect each other at point P. Okay, and they have given that the ratio of AP upon CP. Can you see that? AP upon CP is equal to BP. Can you see that? BP upon PD. You can see BP upon DP. The ratio of these two corresponding sides are equal. They have given it over there. Prove that triangle ABP, triangle ABP is similar to triangle CDP. They prove that CDP. Can you see that over there? Yeah, they told that these 2 triangles to be proved similar. Very, very simple. In this case, first of all, I'll be writing over here in, can I go in triangle? The name of the triangle is what? ABP and triangle. Here we have to prove that triangle CDP. Please don't write here similar. We are starting with this over there. So for the starting, you have to write this over there. That in triangle, which triangle we are going? In triangle ABP and triangle CDP. Yeah, we have to go through that thing there. We have to write that over there. These 2 triangles are. We are going in this 2 triangle. And if you check this out over there, it's very simple. You have over here AP upon CP is equals to BP upon DP. This has been given to you all over here. Now if it is given in your question, now can you see that over there? The ratio of the corresponding side, 2 corresponding sides are equal. And now you can make it out that this triangle, their 2 lines are intersecting. If the 2 lines are intersecting, you have done in your 9 cents also. Then you can have one angle between them. Can you see this? Angle APB and angle DPC are congruent to each other. And you know which angle is this? These are the vertically opposite angle and this vertically opposite angle. So can I write over here that angle APB is congruent to angle here in this case DPC, and you have to write it over here vertically opposite angle. We have here vertically opposite angles. This is the vertically opposite angle. And we got it over there. Now if you check in the diagram that these two triangles will be similar by side angle side. Can you see that side angle side? So can I write it over here that a triangle ABP is similar to triangle CDP, and I have to write it what? By SAS test of similarity. Can I write that over there? So simple it is. Similarity chapter is very simple. If you understand the main concept, it is very simple. So here you can see this, the ratios of the ratio of the corresponding sides. Two corresponding sides have been given to us, and I have proved one is the vertically opposite angle which was not given. We have got it over there, and therefore the two triangles are similar by SAS test. So we have done that A test common sum. We have done side test common sum, and now we did SAS test common sum. Okay. Yes, students. Now let's go to the question number 4 from the practice set 1.3. Now let's read out the question first. Okay, what has been given in triangle ABC? You have a full triangle ABC. AP is perpendicular to BC. AP is perpendicular to BC. BQ is perpendicular to AC. BQ is perpendicular to AC. B, P and C are putting a point. B, P, C are putting a point. A, Q, C are putting a point. A, Q, C are putting a point. Then prove that triangle CPA. Where is the CPA? CPA. You can look at the triangle CPA and the triangle CQB. Where is CQB? CQB. Is this two triangle? We have to prove similar. This is the one question we have to do it. Then they have given the value of AP value. They have given it what? 7. AP they have given it what? 7. BQ they have given it what? 8. BQ ka value they have given it 8. And BC ka value they have given it what? 12. You have a BC ka value is 12. Now here they told to find AC. They told to find AC. Now two things in this question they told to point it over here. One is your triangle you have to prove similar. And there is one thing they told to find AC ka value. Two questions are there in this case. So here for a time being, what I'll try to do to here, I'll draw a separate diagram for you all from this diagram only. But in the exam, we don't need to draw a separate diagram. For you to understand, I'm drawing a separate diagram. Now if you check this out over there, that how to do this over there is I'm drawing a triangle AB. You can see this triangle, which is the triangle they told, triangle CPA. So you have here CPA. You can see this CPA, this triangle, and one more triangle is there, that is your triangle CQB. CQB. So if I go for CQB triangle, it will be this way. I'll be having here 90 degree Q, C and B. Yeah. So if you check this out, the APC I have drawn this triangle, and I have drawn in triangle CQB. This two triangle I have drawn it separately so that you can understand this. I have to prove this two triangle similar. So it's very simple and very easy. So first of all, I'll be going what to write over here. I have to write in triangle CPA and triangle CQB. I am going in this two triangle. I have to write first. Can you see that over there? There are some angles. The side is not given. Angles are congruent. Here you can see that over there. Here in this case is angle. Can I write over here? Angle APC is congruent to angle CQB, and that is what you have to write. What? Each 90 degree, because they are right angle triangle. This is they are right angles over there. APC congruent to CQB. Then one more thing you can make it out over there. From this triangle you can look at that over there. There that C is coming common over here. C is coming common. You have this angle and this angle. Angle C is coming common angle for both the triangles over there. So can I write over here angle ACP. You have your ACP congruent to angle QCB. And I have to write it over here common angle. Common angles. So now when I write this common angle over there, so because it is coming in both the triangles over there, common angle. Now, this two, I have proved this two angles of the triangle, two corresponding angles of the both the triangles are congruent. So then what I can say? Can I say that triangle CPA is similar to triangle CQB? And by, you have your by a test of similarity. A test of similarity. Can I have that over here? A test of similarity. Now, what I'm going to do to here is, after this, that is your first question got over. Okay? We got first question is finished. Now let's go to write down the second question to find AC. So first I'll write down the values what is there. They have given what AP ka value is what 7, and they have given BQ ka value has been given what 8. BQ ka value is what 8, and then BC ka value they have given it over here is 12, and they told to find the AC ka value. Now here in this case, can I have over here that I have to take the corresponding sides of similar triangle. If the triangles are similar, then the ratio of the corresponding sides are equal. Everybody knows that. Triangle is similar, then the ratio of the corresponding sides are equal, and the corresponding angles are also equal. So now already the triangle I proved this two similar. So then the ratio of the corresponding sides will be equal. So can I take it out the corresponding sides? First I am taking what? AC. Can you see? Look at that. AC is acting as the hypotenuse of this triangle, and BC is acting as the hypotenuse of this triangle. So what will be there today? Can you see that today? Hypo upon hypo. That is what I can take it over here. AC upon BC. AC upon BC. Can I have over here AC upon BC? Yeah. Then because this is hypo and this is hypo, so hypo upon hypo has to be taken. Then you have AP. You have got it over here. AP upon BQ. Can I have over here AP upon BQ? This is your AP and this is your BQ. Oh, and here you have to write it over here corresponding. You have to write it corresponding sides of similar triangle. Corresponding sides of similar triangle. Yes. Now what I'll try to do, I'll substitute the values. Now AC ka value they told to find out. So I'll be writing over here AC. BC ka value they have given it over there 12. So therefore you will be getting over here AP ka value 7. And BQ ka value is what? 8. So BQ ka value we got it what? 8. Now what to do? Cross multiply. Let's try to cross multiply. AC, what will happen over there? AC will go and multiply with 8. 12 will go and multiply with 7. So I'll be multiplying over here. AC into 8 is equals to 12 into 7. Now what is happening over there? AC will remain there, and 12 into 7 upon 8. It will come and divide. So 4 2s are 8, 4 3s are 12. So you will be getting, therefore you will be getting further cancellation is not possible. So AC is equals to 21 upon 2. So when you divide this AC 21 upon 2, you will be getting 10.5. So what you got the value of AC is 10.5. So I have proved both the questions over there. I have proved the two triangles they told to prove the similar, and they have told to find the value of AC. And I found the value of AC as 10.5. Okay.